there are three other functions besides sine, cosine, and tangent that are called trig functions. They are the reciprocal trig functions. Before I introduce those, let's just remind you what a reciprocal is and some reciprocals of some common numbers that you may have forgotten. So if we have, let's make a little chart. Here's the number and here's the reciprocal of the number. So if we have a whole number like 2, its reciprocal is 1 divided by 2. If we have a fraction like 1/3, its reciprocal then would be 3 over 1, which is 3. Or like 3/4, which would be 4/3. The reciprocal would be 4/3. The reciprocal of 1 is just 1 divided by 1, which is still 1. The reciprocal of -1 is 1 divided by -1, which is still -1. So -1 and 1 are reciprocals of themselves. The whole idea is that you can multiply a number times its reciprocal and you get 1. So 2 times 1/2 is 1. 1/3 times 3 is 1. 3/4 times 4/3 is 1. 1 times 1 is 1. -1 times -1 is 1. But we do have a little bit of a tricky situation. If we have a number that is is 0, what is its reciprocal? Well, there isn't anything that you can multiply by 0 and get 1. So its reciprocal is actually undefined. 1 divided by 0, undefined. And likewise, if we have a number, if we have a place where a number is undefined, its reciprocal would be 0. Okay, so knowing that kind of to start out with, let's define some of our reciprocal trig functions. So here is the trig function, and here is its reciprocal. So sine, actually I want to start out with cosine. So we have cosine, which we abbreviate cosine of theta, is equal to adjacent over hypotenuse. Its reciprocal is called secant, which is abbreviated SEC, and that is, secant of theta is hypotenuse over adjacent. We have sine. Sine of theta is opposite over hypotenuse. Its reciprocal is called cosecant, which is abbreviated CSC. Cosecant of theta is hypotenuse over opposite. Now right now you're probably saying, unfair, unfair, why don't the cos go together? Notice cosine goes with secant and sine goes with cosecant. And I'm sorry about that, but that's just the way it is. You're going to have to remember that. Okay, third one, easy to remember, tangent. Tangent of theta is opposite over adjacent. Its reciprocal is cotangent. Those are easy. Those go together nicely. Cotangent, abbreviated COT, then is adjacent over opposite. Now let's look at the graphs of these functions, and then we'll in another video we'll look at how to do some problems with this. So looking at the first one, let's do y equals secant of theta. So what I want you to picture here is, let's picture underneath maybe the graph of cosine of theta. So if this is secant of theta, here's our cosine graph. Our cosine goes from 1 to -1, and I'm going to kind of space it exactly out the way this is, all right, with a 0, 90, 180. Okay, so we're just going to make a little sketch of our cosine graph. The cosine graph starts up high, goes down to -1, goes back up like this. So it's key, we've got our key points at 90 and at 180 and 270 and 360. Okay, so here are the key points we're looking at. So let's think about what happens at those key points. So where cosine, so let's think about theta. Sorry, I'm going to make kind of three. So theta, cosine of theta, and secant of theta. So let's think about at 0. 0, cosine of 0 is 1. So secant is also going to be 1 because 1 is a reciprocal of itself. Okay, so we have a point right here. So any place where cosine is 1, secant is going to be 1. So I'm going to go ahead and mark those places. And at 180 degrees, cosine is equal to -1, and secant will also be -1 because -1 times -1 is 1. So we can mark those values. They are the same. Now at 90 degrees, cosine is equal to 0. So that makes secant equal to undefined. So every place where cosine is 0, which would be 270, 90, -90, and -270, cosine is undefined. So there's going to be an asymptote there. So what we have so far is an asymptote that the high and low points match. Okay, the maximum minimum point, they match. They're the same for both secant and cosine, but then we have asymptotes. That's not enough to know what the graph does, so we need a couple of additional points. So we want to look at places where cosine is equal to either positive or -1/2. So when cosine is 60, 120, 240, and 300, that is where we have a 60-degree reference angle. Okay, so when we're talking about a 60-degree reference angle, cosine is going to be 1/2. All right, so cosine is 1/2 here. It's -1/2 in quadrants 2 and 3, and then it's +1/2 again in quadrant 4. So we're going to have +2, -2, -2, and +2 will be my secant values because it's the reciprocal of the cosine values. So if we look at 60 degrees, this would be 30, 60, 90. So 60 degrees, we're going to be at 2. 90, 120, another 30 degrees, -2. 180, 210, 240, -2. 270, 300, +2. So basically what we have here are little curves that go in between the asymptotes. There'd be another +2 here. These would both be -2. And this would be a +2 here. So if we meant that's what the secant graph looks like. So what happens is actually the cosine graph kind of fits right in between the secant graph. So this is the cosine graph right here. This is cosine of theta. Okay, is the red graph. The secant graph is the black graph. So notice the cosine graph never goes higher than 1 or lower than -1. The secant graph is always higher than 1 and lower than -1. It doesn't have anything in the middle, and it has some undefined values. The sine is very similar. So if we look at the sine graph, so I'm going to draw a little sine graph underneath. So this is y equals, use the same color scheme here, y equals cosecant of theta. That is the reciprocal of sine. So this is y equals cosine theta here. I'm going to do y equals sine of theta here. So I'm going to make the same axes, 90, 180, 270, 360, and so forth. So they're right underneath each other. Now, remember sine starts at 0, goes up to 1 at 90, goes back down to 0, then back to -1, and then back up to 0. And then it goes in reverse here. Okay, so key points are these. Maybe I'll make them in red like I did before. Here are my key points. So this is going to be exactly the same as cosine was. Every place where sine equals 0, so if sine of theta equals 0, cosecant of theta is going to be undefined. So that would be at 180, and at 360, and at 0, and at -180, and -360. So notice I'm picking the places where sine equals 0. Cosecant is going to be undefined. Now wherever sine of theta equals 1, cosecant of theta equals 1. Wherever sine of theta equals -1, cosecant of theta equals -1. So they're going to share these points. So we have a point here at 91 and 270, -1, and so forth. All right, so we have those points. And then we're going to have the same thing going on with the 1/2. So only in this case, sine of 30 equals 1/2. Sine of 150 equals 1/2. So that means cosecant is going to be 2, and sine of 210 and 330 equal negative 1/2. And so cosecant is going to be negative 2. And where do those come? Those are close to the asymptotes. Here's 30 right here, and here's 150. So at 30 we're going to be at positive 2. At 150 we're going to be at positive 2. I'm going to get those marks off because they're kind of confusing. Then when we get to 210 and 330, we're going to be at negative 2. So notice where I'm below the x-axis, this is curving down. Where I'm above at the x-axis, this is curving up. Curving down, curving up. So here we have our curves. Students will say they look like parabolas, but they're really not parabolas, but they are curves that I guess sort of remind you of a parabola. And so once again, if I were to draw in my sine graph, it would fit exactly inside the cosecant graph, and they would just share in common the points at 1 and negative 1. Okay, so this is y equals sine of theta, and this graph here, the black one, is y equal cosecant of theta. Okay, I think I'm going to stop right here, and then I'll make a separate graph for tangent because this one's getting kind of lengthy, and so we'll put the tangent graph on the next. Nah, I changed my mind. We're going to do tangent on this graph, this one too. Get it all done in one equation. Okay, so once again, I'm going to draw my tangent graph right underneath here. Tangent is, think of slope. So think about your 90, 180, 270, and 360 on your unit circle. So you got your unit circle, 0, 90, 180, 270. So remember, every time we're horizontal, tangent is equal to 0. So that's 0, 180, 360, and so forth. Wherever we are vertical, okay, we have asymptotes. Asymptotes here, 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 here. Then halfway in between 90 and 0, we have a slope of 1, so we have a slope of 1 here, and we're going up each time, like this, curving up. Okay, so now let's think about wherever tangent of theta equals 0, cotangent of theta is undefined. So we're going to, every place I have these red dots where tangent of theta is 0, cotangent is going to be undefined. So cotangent is undefined at 0, 180, and 360, and negative 180 and negative 360. Wherever tangent of theta is undefined, cotangent of theta equals 0. So wherever there's asymptotes here, then cotangent is going to be 0. Now, don't stop and think, oh, I know, now we just make the curves, okay? There's going to be something different about this. Where tangent equals 45 degrees, I'm going to put a kind of star by this, where tangent of 45 is equal to 1, that means cotangent of 45 is still 1, because 1 and 1 are reciprocals of each other. Okay, so notice this point right here, where tangent of theta is equal to 1, cotangent of theta is still equal to 1, not negative 1. And down here, where tangent of theta is equal to negative 1, cotangent of theta is still equal to negative 1, because negative 1 and 1 are negative 1 and negative 1 are reciprocals of each other. So the 1s and the negative 1s stay the same, just the zeros and the asymptotes switch places. So what that does in effect is cause a curve that goes downward instead of upward. So the curve goes downward in between the asymptotes. So the asymptotes switch places with the zeros, and the curves go down instead of up for cotangent. So this is the graph. I guess I never labeled this. Y equals cotangent of theta. This is the graph y equals tangent of theta. So those are all your reciprocal graphs.